problem, but I'm changing the problem a little bit. I'm changing it to a let's verify it. And I want to prove it is equal to sine squared. Let me give you some hints on this. I'm taking this problem and giving you some hints on how you approach these. First of all, are y'all finished talking? Because I'm trying to teach you something here. First thing you're going to try to do is, basically, it doesn't matter which side you work on, but you work on just one side. It's easier to make something hard look easy than it is to make something easy look hard. So you usually work on a more complicated side. The things you can do is you can factor, you can multiply by conjugates on top and bottom, but that's much later down the line. And you can use any trig identities, or you can multiply out. In this case, do you have an idea?
Take out a sine squared.
Thank you. I think you're going to do well on this part.
This part.
Sine squared. In other words, doing well on this part just means can you look at it and think of something to do. Whether it's right or wrong, try it. It might be right. There's not going to be a say, I must do this in this part. And that would give you cosine squared theta, plus sine squared theta, right? Now use an identity. That's like Danny said, that's 1.
Does it equal 1?
So what do you have for an answer?
Sine squared A.
Right, it worked. Put a check when that side matches that side.
What?
What? What?
You lost it after the second step when you did the common factor.
You don't know how I took that out?
No, I knew that one. After that, you
Look
lost
at your
me.
identities.
Right, I see that, but
You see that, but
That equals 1. And sine
that
squared A
identity
times
equals-
1 is sine squared A, which equals sine
look
squared
at
A.
your identity.
oh, so you just dropped the other one?
What is cosine squared plus sine squared?
Yeah, you just totally.
Say again?
What is cosine squared plus sine squared equal to? Look at your identities. I gave you the list of.
1. I see it. I know
What?
1.
What do you mean I just dropped it? I'm trying to prove that sine squared equals sine squared.
What about the other one? There's 2 sine squared A's.
I'm not paying attention. What do I do?
That equals 1.
Okay. So you
I
just
don't-
thought you divided by the common factor one. That one. What did you get rid of that one?
That is my answer. Sine squared theta equals.
I think Shaw understands more this than you, Luke.
If you knew that sine squared plus cosine squared equals 1, you would know how to do that, right?
Sure.
Right.
What class is this?
Pre-cal.
I'm glad I'm not a
Well, alrighty.
This part isn't.
I'm going to ask you to prove this. This is a very easy one. Prove that 1 minus cosine x times 1 plus cosine x equals sine squared x. That's an easy one. Two-stepper.
1 plus
Yeah, you
cosine
would.
x squared equals.
Use your identities. You put up the 1 minus.
Oh,
plus,
because-
Yeah,
You put it
multiply those
together.
out, right?
and then you have
Yeah,
1
then
You
minus
get
Yeah.
1
cosine.
minus cosine
Sine
squared
squared
x,
x,
which
which
is
is-
not quite there, but one more step it is.
The
So it's a
identity.
two-stepper.
That's basically, that's the same as 50, but instead of 1 minus cosine, it's 1 minus
Where'd you get the cosine from? See, in the book it says 1 minus sine of x, not cosine.
Look, it's the same thing, man.
Oh, okay. Now I changed the problem. If I gave you 50, you would multiply 1 minus sine x times 1 plus sine x and get 1 minus sine squared,
Still recording?
which is therefore cosine squared. Okay, I want you to do this problem for me. 51, we're going to verify this. All these are tricks that you're going to be using in the problems that you're going to be doing. Cosine 4 alpha
Take out a cosine squared sine squared.
plus 2 cosine squared alpha sine squared alpha plus sine 4 alpha. Is that what it said? Prove it equals 1.
Take out a cosine squared sine squared.
You don't have it all the way through, you can't do that.
Why?
It's one
In
of
order to
those,
take
Oh
out
yeah,
some
never mind. Never
isn't
mind.
it, that's kind of like where you can, like,
factors, yeah.
Well, first take out a cosine
Trifactor.
squared and then take out a sine squared. Like out of, cause you have two parentheses, you can, see what I'm saying?
It's cosine squared.
Take out the cosine squared of the first one and the sine squared of the second one.
It's a perfect square.
It's a perfect square.
Cosine squared plus sine squared.
This is the same thing as cosine squared
you can do it that
alpha
way, couldn't
plus sine squared alpha
So that's 1 times 1.
squared. Cause it's a perfect square.
So
It's
that's
like,
1
it is
squared.
like x to the fourth plus 2x squared y squared plus y to the fourth. That's exactly what it's like.
Pretty much what I just said is the same thing.
Maybe.
Which
I
cosine
didn't follow
squared?
it, but maybe if I could see
Like,
it on
you
paper,
have two
I could judge.
parentheses, the cosine,
Oh, okay, I know what
and then
you're
you just
saying
take them
now.
out.
Okay, yeah,
you
you're
do the
right.
same thing.
You're right. And what does that equal?
1
One.
squared.
And 1 squared is
Or-
1.
No.
See, what I did here was not, multiply, but I unmultiplied, which is called factoring. Okay, we have one more. I want you to prove 52 equals 2 sine x.
Nothing.
Whatever. I'll ask later.
Equals
Oh,
2
I
sine
got it.
x? Is that what you said?
Yeah.
Cause
Cause
tangent.
tangent.
On 51, did you cancel out the
Cosine.
cosine squared theta plus sine squared theta?
No, I replaced it with a 1. I didn't cancel it out.
Yeah, I think I got it. Cause
Why?
tangent is sine over cosine.
Is that what it said for the, yeah, okay. Alright, so what'd you do, John Michael?
Tangent is sine over cosine.
Alright,
so
tangent is
cancels out.
sine
Easy peasy.
over cosine, and this
I like
multiplied
these.
by cosine, and it's
I
a
don't
sine.
do the other
You
one.
Right?
cancel those out and you're left with
You
cosine.
cancel those out, and you're left with sine plus sine,
23.
which is the 2 sine.
I didn't do 23 third grade. I wasn't listening. I don't know what it was.
Okay, open to page
Uh,
366.
Triangle.